Hello. In this video, we're going to continue graphing rational functions, and we're going to look at some pretty advanced ones. So here we're going to graph the function y equals x squared over x squared plus 2x. Now to do this, the basic technique is that we want to find the asymptotes because they're going to be guides for our graph. We want to find some points in each section, and then we want to connect the dots. So right away, let's look for that vertical asymptote. So the vertical asymptotes would be, well, we have to factor this, so x plus 2. Vertical asymptotes are any values that make the denominator 0 that don't cancel out with the numerator. So, maybe we should do some simplification here. Let's go ahead and take our function and write it as x squared over x plus 2. We'll cancel out one of the x's, and that will give us x over x plus 2. Okay, so this means that we have a vertical asymptote at x equals -2. So we can put that on our graph, x equals -2. Because that x canceled right there, we're going to have a hole at x equals 0. And if we plug that in into our new equation, y is going to equal 0 over 0 plus 2, which is 0. So the hole is going to be at 0, 0. There's our hole. We're going to have a horizontal asymptote because if you look, the degree of the numerator is 2, the degree of the denominator is 2, so it's a balanced, and that means we take the leading coefficient of 1 over 1. So the horizontal asymptote is at y equals 1. And then we definitely need some points on either side of that vertical asymptote. So let's go ahead and make a little table, x and y. Let's do -1 and -3. Now again, you can use the simplified version, you can use the original version, it doesn't really matter. Let's go ahead and try the simplified version, so that will give us -3 over -3 plus 2, which is -1. So that will be 3. So we got one right here. And then if we do -1, that'll be -1 over 1, which is -1, right there. So now we have our asymptotes, and we can recognize that, well, over on this left side, we have to go through this point, and we have to approach the asymptotes. So we're going to have a swoosh right there. Same thing over here. We're going to go through this point and the hole, approach the asymptotes, and we get a swoosh over here. And so while the initial function might look very complicated, as long as we simplify it to determine any holes, as long as we recognize the vertical asymptotes from the denominator, the horizontal asymptotes from our rules for horizontal asymptotes, we can get a lot of information on the graph, right? The hole, the vertical, and the horizontal asymptotes. And then we simply grab some points on either side of the asymptote and connect the dots with our swooshes. Now, it's not always going to be swooshes, but if we have a situation like this, it definitely is going to look like that swoosh. So let's go ahead and try another one. So here we have the function y equals 3x squared minus 48 over x squared minus x minus 12. And I'd encourage you to pause the video and give it a try. At the very least, factor it down, see what the asymptotes might be, and even if you can't get the full sketch, at least get as much information about the graph as possible. All right, so assuming you gave it a try, let's factor out that 3 in the top. That'll be x squared plus minus 16. In the bottom, we're going to have x minus 4x plus 3. We can further factor the top as x minus 4, x plus 4, over x minus 4, x plus 3. Now remember, because this cancels out, it's not actually going to be a vertical asymptote. It's going to be a hole. But the remaining factor will be. So we're going to have 3x plus 4 over x plus 3. And so we have here a whole at x equals 4 and y equals, well, we plug that into the simplified version, so 3 times 4 plus 4 over 4 plus 3. 4 plus 4 is 8. 8 times 3, 24. So we have 24 over 7 for the y value. Let's grab that vertical asymptote. That's going to be at x equals -3. Let's grab that horizontal asymptote. Again, we can look at the leading coefficient there and there. So we got the invisible 1 on the bottom, the 3 on the top. So y equals 3 over 1, which is 3. 1, 2, 3. And 1, 2, 3. And we have the whole at 4. 1, 2, 3, 4. Now the number we have is 24 over 7. That's going to be just a little bit more than 3. So it's going to be just up here, just above the asymptote. Now we can make a little table. Let's pick a number just to the right and just to the left. So -5 and negative. We could do even -4. -4 and -2. If we plug that into this, when we plug in -4, it's actually going to be nice because in the top we're going to get -4 plus 4, so it'll be 0 on the top. So we're just going to get 0 here. So -4 and 0. When we plug in -2, we get 3 times -2 plus 4 over -2 plus 1, or plus 3, sorry. So that's 3 times 2 over 1, so 6 over 1, 6. Okay, so we've got -4 and 0. That's going to be right here. And -2 and 6. It's up here. And now we simply connect the dots. We see a swoosh shape over here. And a swoosh shape over here. Might be nice to extend that asymptote just a little bit, so we can add our arrow here. Maybe extend the asymptote a little bit there. All right, and there is our sketch of the rational function. So we got another one here. We want to graph y equals 3 over x squared plus 3x. Again, pause the video and see what you come up with. Assuming you gave it a try, we should have x plus 3 as our factor on the bottom. And since nothing cancels out, those are both going to be vertical asymptotes. So x equals 0 and x equals -3 are vertical asymptotes. Holes, none, no holes. Horizontal asymptote, it looks like it's going to be bottom heavy. The degree on the bottom is 2. It's bigger than the degree on the top, which is just 0. So it's going to give us a horizontal asymptote at y equals 0. So let's go ahead and do those vertical asymptotes at 0 and at -3. And let's do that horizontal asymptote at y equals 0. Now in this case, because we have 2 vertical asymptotes, our table is going to need to be a little bit bigger. We're going to need a point on the left, so that's going to be at -4. Then it's probably a good idea to grab both points in the middle, so -2, -1. And then we need definitely a point on the right. So let's plug each one of these into our function. So when we plug in -4, we'll get 3 over -4 times -1. So that's 3 over 4. At -2, we're going to have 3 over -2 times 1. So -3 over 2. At -1, we'll have 3 over -1 times 2. -3 over 2. And at 1, we'll have 3 over 1 times 4. So 3 over 4. Let's go ahead and put those on the graph. So we've got -3 over 2. Okay, so that's going to be down there, and then 3/4. So let's start over here. -4 and 3/4 is right about there. -2 and -3/4 is there, and then up here we have, again, 3/4. Now the sections here, I think, are pretty clearly swooshes, because again, the asymptotes are our guide, and we have to go through these points. So we're going to have nice, beautiful swoosh graphs there. But in the middle, this is definitely a weird, it's like, what's going on here? How do you connect these dots and then approach asymptotes? I don't really know. It seems confusing. And so unfortunately, in this situation, the 2 points that we added don't give us enough information. We need more information. We need to pick some fractions. So it's up to you whether you want to try a little bit closer to this asymptote and a little bit closer to this asymptote, but we need more information. So let's start with x equals -1/2. So that's going to be picking a point right over here. So if we do that, we're going to get 3 over -1/2 times -1/2 plus 3. Now that's definitely some tricky fraction work, but if you work it out, you'll get -12 over 5, which is a little bit more negative than 2. So that's going to be down here. Now this is really crucial because this tells us that right here, the graph is going to go down and approach the asymptote. I'll leave it for you to try. But if you make another point over at here, -2.5, your y value you get should actually be the same thing. You're going to get another -12 over 5, or if you're using a calculator, -2.4. So over here, you're going to get the same point right there. So this tells us we're going down. And in fact, we can kind of connect these dots here with a little U shape. And so in between the two asymptotes, we have a U, or in this case, or an N, an upside down U. Now this is interesting. On this side, we have a swoosh, and here we have a swoosh. But here we have an upside down U. And this is going to, we can just kind of summarize the different types of shapes that could occur on a rational graph. So if you have something like this, really all you're going to have are either swooshes here, or here, or here, or here. Those are the only ways you can approach the asymptotes. It's just all swooshes. But if you have something like this, now there's some more options. One thing you could do is you could have a U shape. But another thing you could do is have a regular U, not an upside down U, but a regular U shape. These are both going to be valid shapes. And in fact, there's another kind of shape you could have wedged between two vertical asymptotes. It would look like this. You'd approach this top one and then approach the bottom one. I call this like an S curve. It looks, if we do it the other way as well, have the two asymptotes here, and then go from the bottom and then this way. It's kind of like an S curve, and it's an interesting shape. These are the other options we could have. We could either have the U, the upside down U, the S curve, I call this like an S curve, or another S curve. And it's interesting. These are the shapes. Now, we don't have anything more than this, so don't get panicked. When you have two vertical asymptotes, it's not like it gets crazier than this, but I would agree, this is definitely an interesting, there's more variety, more going on here. The way you determine which type of shape you have, once you've seen them all, is you simply just pick more points until you can determine which kind of shape you have. For the swooshes, you only need 1 point, and you can determine which one it is. For the U's and the S's and the upside down U's, sometimes you need 2 or 3 points in between the asymptotes. So go ahead and pause the video and give this one a try. Find your asymptotes, your vertical, your horizontal, any holes. Then make sure that you have enough points, connect the dots, and see what you come up with. All right, so this will factor as 3, x plus 1. And in the bottom, we're actually going to need to use a little synthetic. So let's maybe do that over here. We have x cubed plus 0x plus 0x squared, and then plus 1. So when we do the synthetic, 1, 0, 0, 1. And we're going to try that negative 1. So 1, negative 1, negative 1, 1, 1, negative 1, 0. So this will factor as x plus 1 times x squared minus x plus 1. Now that quadratic doesn't factor anymore. You can check with the quadratic formula or the discriminant. And this is going to cancel. So that's going to give you 3 over x squared minus x plus 1. So because this doesn't factor, so here, no factors, therefore no vertical asymptotes. We do have a hole though, because we had x cancel, so x equals negative 1 is our hole. And then we have to plug that in to get the y value. So y is going to be 3 over 1 plus 1 plus 1, which is 3 over 1 or 3, or 3 over 3, sorry, which is 1. So we've got a hole, we've got no vertical asymptote, and our horizontal asymptote. Well, it's going to be bottom heavy, so that's just y equals 0. Okay, so we put our horizontal asymptote on. We grab our hole here at negative 1 and 1. And now we say to ourselves, well, this is a little weird. We're used to having vertical asymptotes to help us sketch the graph. We don't have any vertical asymptotes. So maybe on the last question, you kind of panicked because you said, oh no, there's so many vertical asymptotes, this is hard to sketch. But I would argue that the vertical asymptotes help you sketch the graph. On something like this where we don't have vertical asymptotes, we're a little bit panicking. There's no guidelines. What do we do? And so again, when you don't know what to do, you always go back to a table of values. So let's pick some points here. Let's go maybe negative 2. Then we already have negative 1 as the whole, and we'll go 0, 1, 2, maybe even 3. And so pause the video and see what you get for a table here. Okay, so when you plug it into the simplified version, this should give you 3 over 4 plus 2 plus 1, so 3 over 7. When you plug in 0, you'll just get 3. When you plug in 1, you also get 3. Plug in 2, you should get 1. And then if you plug in 3, you're going to get another 3 over 7. Okay, so let's plot those points. We've got negative 2 and 3 over 7. We've got 0 and 3. We've got 1 and 3. We've got 2 and 1. And then 3 and 3 over 7. So we've got these points, and we've got to connect them. So we go here, 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 like that. And then, well, we have to approach the asymptote, so let's kind of flatten out. And there we go, there's our graph. This is the graph of the function. I know it looks a little funky. It's almost like just like a little hill, sort of on a flat prairie, like a little bump. But we have to approach the horizontal asymptote. So that means we're going to kind of have that like sort of trailing sort of side of a swoosh here and side of a swoosh here. And then in the middle, we just plot the points and we get this shape. Again, the vertical asymptotes help us because they give us guides, but even without vertical asymptotes, we can still figure out what to do by just creating a nice table. All right, so let's take some notes on this. This is graphing rational functions. This is the full meal deal. This is the hardest they get. These are using all the skills. So how do we do it? Well, we want to find vertical asymptotes from the denominator. We want to find horizontal asymptotes with our rules. We want to find any holes when things cancel. Then you want to make a table. And usually I say 1 point per section. Sometimes you need more than that, but at least at the very minimum, 1 point per section. And then you connect the dots. Connect the dots. All right, so here's a graph for us. We have y equals 2x minus 10 over x squared plus 5x. Go ahead and pause the video and see what you get. All right, so assuming you give it a try, you should end up with 2x minus 5 over x plus 5, which means nothing cancels, so there's no holes. So for this one, I would say that the holes are none. The horizontal asymptote is going to be y equals 0 because it's got a degree of 2 on the bottom and 1 on the top. The vertical asymptotes are going to be at x equals 0 and x equals negative 5. Now we have to make a table here for some points. So let's go ahead, we'll put these asymptotes on here. Put one there, and one there. This is at x equals negative 5. Then our x and y table could be, well, I guess we could try negative 6 on the one side. And then we could do negative 4, negative 3, negative 2, negative 1, and 1. That should give us a whole lot of information. So as you work these points out, you should get negative 11 over 3, 9 over 5, 8 over 3, 7 over 3, 3, and negative 4 over 3. All right, so let's take a look. We can maybe add a little bit here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Maybe I'll put these points here. Yeah, I'll do them in red. So at negative 6, we're going to be down at about between negative 3 and 4. So kind of down here. And that's going to give me clearly a swoosh like this. Over on the right side at 1, we're going to be down at negative 4/3. So again, that's down here. We have a swoosh over here. And in the middle, well, this is where it gets a little interesting. We're going to be up at 4.5. So that's kind of right there. And then we're going to be at like, 2 point something, almost down to 2. So kind of here. And then here. And then over at negative 1, we're back up to 3. So it looks like we have this U shape in between the two vertical asymptotes. All right, and there's our final graph. Now for some extra practice, you can definitely try worksheet 9 and 9.5. And then any things to remember, I would definitely recommend you look at the possible shapes. So we either have the U, the upside down U, the S curve, the other S curve. So these are the potential shapes between two vertical asymptotes. And you just need to plot enough points until you can identify which of the 4 you have. All right, hopefully you enjoyed this video. And as always, thanks for watching.